Okay, let's dive into a really essential topic for your GCSE chemistry exam: polymers. If you're following the AQA specification, this is your complete guide to section 4.7.3, broken down so you can absolutely nail the key concepts.
It sounds like a bit of a trick question, doesn't it? But the answer is actually really simple: polymers. Yep, that one word connects a plastic bottle you might have on your desk to the DNA inside every single one of your cells. So let's find out how.
So here's our game plan. We'll kick things off with the absolute basics. Then we'll get into the two main ways polymers are made: addition and condensation. After that, we'll check out some of the amazing polymers found in nature, and we'll wrap it all up with a super fast summary of everything you need to know for your exam.
Right, before we get into any of the cool reactions, we need to get 3 essential terms locked down. Seriously, getting these right is the foundation for everything else that follows.
First up is the monomer. The easiest way to think about a monomer is like a single Lego brick. It's the small, simple molecule, the individual repeating unit that you use to build something way, way bigger.
So, what happens when you click hundreds or even thousands of those Lego bricks, those monomers, together? You get a polymer. This is your finished product, a huge molecule that's basically the complete Lego model built from all those individual pieces.
And finally, we have polymerization. This is just the name for the chemical reaction itself. It's the process of joining all those monomers together to make the polymer. So let's recap those 3 key terms: monomer, the brick; polymer, the model; and polymerization, the building process. Got it? Good.
Okay, now that we've got the definitions sorted, let's look at the first of the 2 ways we can actually make a polymer. This one is called addition polymerization.
The absolute #1 thing to remember for addition polymerization is what you start with. It always begins with unsaturated monomers called alkenes. And the crucial bit about an alkene is that carbon-carbon double bond. That double bond is where all the magic happens.
This breaks it down perfectly. You see, in each little monomer, that carbon-carbon double bond basically breaks open. This frees up the monomers to link together, forming one long continuous chain. Now pay really close attention to step 4, because this is the defining feature. The only product you get is the polymer. Nothing else is made, nothing is lost. A classic example, and one you'll definitely see in your exam, is the polymerization of ethene. All the little ethene monomers join up to form polyethene, which you probably know better as polythene. You know, the stuff used for plastic bags and bottles? And the naming is super easy to remember. You just stick the word poly in front of the monomer's name.
Okay, quick heads up. This next bit is for higher tier students only. We're going to look at a slightly more complex process now, called condensation polymerization.
So what's the big deal with this one? Well, the key difference is right there in the name. The monomers here have 2 functional groups, and when they react and join together, a small molecule, and it's usually water, is produced and then lost. That's why it's called condensation. That little water molecule is kind of condensed out of the reaction.
This slide, this is pure gold for your revision. It puts the 2 processes head to head. So, for addition, one type of monomer, the alkene, its double bond opens, and you only get the polymer. But for condensation, you often have 2 different types of monomers. Their functional groups react, and you get the polymer plus a small molecule like water. Knowing these differences is absolutely crucial.
So far, we've mostly been talking about man-made plastics. But polymers are also, quite literally, the building blocks of life itself. And this brings us right back to that opening question about DNA. Let's see how nature makes its own incredible polymers.
Higher tier students, this links back perfectly to what we just covered. Proteins are just natural condensation polymers. The monomers are amino acids, and guess what? They have 2 different functional groups, so they join together, lose a water molecule each time, and form these long chains called polypeptides, which then fold up to become proteins. See the connection?
And now, we can finally answer that question from the start. What does a plastic bottle have in common with your DNA? It's a polymer. DNA is this incredible natural polymer built from 4 different monomers called nucleotides, all twisted into that famous double helix structure that carries our entire genetic code. How cool is that?
This table here is a brilliant summary of the key natural polymers and the monomers they're made from. It's definitely worth remembering these pairs. You can see proteins are made from amino acids, and complex carbs, like starch and cellulose, are just polymers made of simple sugars.
Okay, time to bring it all home. Let's do a quick recap.
If you're revising for your exam, these are the absolute must-know essential facts about polymers.
Right, get these 5 points locked into your brain. Know your basic definitions, monomer and polymer. Know the key feature of addition polymerization, no other product. For higher tier, know the key feature of condensation, a small molecule is lost. And finally, be able to name a few natural polymers and what they're made of. That is the core of this topic.
The goal here isn't just to memorize facts, but to actually apply them. So I'll leave you with a final thought to chew on. We've just seen two very different ways to build a polymer. How do you think those structural differences might affect how easily we can break them down and recycle them? Because that real-world application of the chemistry, that's what truly matters.